Yankees didn't care. They were playing their lesser.
I didn't watch
Yeah.
the rest of it.
Whether they want to
They
watch
probably
it or
wanted
not,
Boston
or
not
they-
to be there.
The ninth inning of the bottom line, but I'm not swinging.
I truly don't think there's any way it's going to stop the Yankees in the playoffs. You never know. Philadelphia.
And they came.
Philly might come around for money, yeah.
But anyhow, we went over this previously, but since we haven't met for a week, let's review this thing about capillary filtration. This is, to me, a very important physiological process. Do remember that as blood enters capillaries, there must be filtration because the capillaries are permeable, and there is blood pressure. That is what we call either blood pressure or blood hydrostatic pressure is the more popular. I think we, for the capillaries specifically, called it blood pressure there, capillary hydrostatic. But it's the same as the blood pressure that's produced anywhere in the body. It's just that that's the part that's going to cause the fluid, along with some solutes, of course, to come out of the capillaries into interstitial fluids. And when this material comes out, it makes that available to the cells. One thing I was going to do and I did not, let me temporarily raise the screen. I want to make a drawing. Maybe this will clarify some stuff for you. Watch me get the screen up and not be
Yeah.
my luck lately. Or else go up with the screen. Here. Pretend this is a capillary. Here's a cell over here. We drew a similar drawing before. Inside the cell is, of course, intracellular fluid. In here, of course, is plasma. What do you call the fluid in between?
Interstitial.
Interstitial. Now this fluid here is interstitial. Now, certainly there are exchanges between the interstitial fluid and the cells. There has to be, materials the cell needs, such as nutrients, etc. Many things, of course, including nutrients, will be going in. And other materials, such as waste, their secretions will be exiting the cell in various ways. Some of the transport methods that we discussed in A&P1 may come to mind for things getting in and out of cells. Simple diffusion is part of it. We have facilitated diffusion. I don't know if you remember these things or not. It's really not important that you do necessarily keep all these in your memory banks, but simple diffusion, facilitated diffusion, active transport. Of course, when water is moving, that's osmosis. You also have endocytosis and exocytosis, where vesicles and vacuoles are formed to take materials in or expelled in. There are numerous complex ways the cell can take materials in and expelled in. So that's part of it. What we're talking about right here now, though, is not that. We're talking about the exchange between the blood and the IF, the interstitial fluid. In comes the blood. It's under pressure, of course. Capillary hydrostatic pressure, as we will discuss later. Because of that, materials exit by filtration. Water and also solutes. There are things, of course, that are too big to exit the blood, hopefully, anyway. There are times when that's not the case, but everything is normal. Most of your proteins will stay in the blood, in all cases for most. Formed elements, of course, you know that whites can go out of the bloodstream, of course, that's an exception to that, but generally speaking, what goes out by filtration is water and any solute that's small enough to be filtered through the walls of the capillary, either through pores between the cells and through the basement membrane. If it can make it through there, it will. And that outward movement we call filtration. Then, on the outgoing side, this is of course the incoming, or what we would call the arterial. You could say arterial or arteriole side, where the blood is coming in. That's where the filtration occurs. I kind of got the air a little bit far down the line here, but that's okay. I'll straighten out later. This would be the venule side, the outgoing side. And there's a movement from here back in. This is called reabsorption. I'll have to hyphenate this, unfortunately. I don't have enough room there. But reabsorption will be the uptake of fluid back into the blood. Some of the fluid we're going to see in our drawing, that I'll show you later, some of the fluid is taken up by the lymphatic system, the next system we're going to talk about, that indeed forms lymph, which is transported, cleaned and transported eventually back to the blood anyway, but there's this continual outflow, filtered out and then reabsorbed back in, with the lymphatic system in here helping a little bit. But what this does, this makes, in part anyway, you got diffusion going on and some other more complicated processes, but what this does, in a big way, is make materials available to the cell. And of course the cell can put stuff into this reabsorbed fluid too, and it can be taken back into the blood. And we will clearly see that the major influence that makes filtration occurs is the higher blood pressure, the capillary hydrostatic pressure. It's just the blood pressure coming into the capillary. As you go across, that declines. And what is responsible for pulling this fluid back in on this side? Draws it back in. Think of the blood as kind of like a water sponge.
Osmosis.
Osmosis, yeah, osmotic pressure. The pull due to the greater solute concentration, particularly proteins in the blood, the plasma, compared to the interstitial fluid. A lot more protein in here and other stuff too. So that tends to draw the fluid back. But only after the filtration pressure, the blood hydrostatic pressure has fallen below. And so that's at least a start, and then we'll look at my more detailed, animated view in just a moment. Have you had time to get that down if you wanted to draw it, or you don't need to necessarily? It's just the beginning of this. So let's go back to the screen then. See what I mean? There you go. Take us in half an hour yet.